All right, so here's the deal. We're going to do a little combo between revolving around the axis and that region between the curves. So we can have a disk method, which is solid right to that x-axis. But what if not everything looks like that, right? What if I have this top curve and this bottom curve? So with these two curves, then I'm going to revolve those around the axis. And look what happens here. Because of that, I have this hole in the middle. So that's why it's called a washer method. So, you know, hardware, if you call it that, that's a washer, right? Nuts and washers. So this is what that is. That's why it's called the washer method, because of that. So it's a circle with a hole in the middle, and it's also a circular hole in the middle. So an outside circle and an inside circle. Now here's the deal. Remember, when you take an integration, it's the area from the top to the x-axis. So what we're looking at here, now I'm going to go with this. So we have this area is going to go the entire way, all the way down to the x-axis. However, whenever I want to find the area of this inside part, that's going to be that much. So do you see what we're doing? If I want to find the difference between the two of these, I'm going to integrate, because it goes all the way to the x-axis, finding the area under the curve from this top one all the way down to the bottom that we have. This part. Nope, nope. Oh, come on, you little stinker. And this part. Do you see what's happening? If I want to find what's between these two, I'm going to take this blue one, this outside function that we have, take that full area, then the area of this bottom curve is what's going to be my inside of that washer, and I subtract it off. If I have this one minus the blue minus the pink, that's going to tell me what's left over, and that's going to be this inside washer. All right? Okay, so I'm still finding circles that we have, but we have to get a little fancy with it, and we're going to take that outside minus the inside. So my volume here for the washer method is still going to go from A to B, right? But we have to account for that hole. So it is pi r squared minus pi r squared. So we can factor out the pi because it's in common, and I take my top function radius squared minus my bottom function radius squared. Right? And the reason for that is because I can look at this. This is the exact same thing as I'm going to go from A to B, and I've got that pi r squared minus the pi r squared. Right? I've got this function, but I can take this pi right here, factor it out, and that's what makes that easier. It's still just circle minus circle. I'm just factoring out the pi because it's in common with both of them, and I don't want to mess with it. All right? Okay, let's try one. So, I should have written this, but I didn't, so that's okay. We'll copy this down right here. So let's try this one. Right here is example 4. The region R is bounded by f of x is equal to the square root of x, and g of x is equal to x squared. And I'm going to take that between x is equal to 0 and x is equal to 1. So that's real tight. What is the volume revolved about the x-axis? Okay, so I'm taking the x-axis, but I've got two different curves here. Two different curves. So I'm going about the x-axis right here. So let's draw this out. I'm going to do 3 of these, and this is going to be a 1, this is going to be a 1. Because if I have f of x, it's going to be 0 and 1. Oh, try again. It's more of a curve on that, like that. This is y is equal to the square root of x. I almost put f of x. That wouldn't make any sense. Or f of x is equal to the square root of x, whatever. And then I've got this square root Oh, for crying out loud, I keep saying the wrong words. It's also going to go to 1, but it's going to come up like this. And this is y is equal to x squared. Do you see that? And then this is happening in between these. This is going to be my region. And this is going from 0 to 1. This is my A, and this is my B. Cool, right? So I've got that 0 to 1 because I'm blocking those off, and that's where they intersect. So I'm going to take this little fella and revolve it about that x-axis. So it's going to look kind of like a weird bowl. I could try to do this a little bit, but we all know my skills in this realm. So I'm kind of going to take this top one, and it's going to go around. And then I've got this bottom that I'm looking at. Honestly, let's do it from the middle here. This is going to kind of be like from this, and then it's going to kind of be like this. Ooh, we all know that's not good. But the point is, you can see kind of what's happening there, right? Okay, so I have my volume is going to go from 0 to 1. I'm going to go ahead and throw pi out front because you know I don't like to mess with it. And so this is my top function, which is x to the 1/2, just because it's easier, squared, because it's still radius squared, minus my x squared. Not too shabby, right? So my volume is equal to pi from 0 to 1. Power to a power you multiply, that just gives me an x, minus x to the 4th, and that's a nice easy power rule. So I've got 1/2 x squared minus 1/5 x to the 5th, and that's being evaluated from 0 to 1. The beauty of that 0 is then it's just minus 0, which is nice. So volume is equal to pi. Then I've got 1/2, obviously 1 squared. You guys don't need me to write that, right? 1/2 times 1 squared minus 1/5. All right, plugging in a 0 is minus 0. So I'm going to push our skills a little bit more here. So I've got pi. If I put these together, I've got 5 tenths minus, and then that would be 2/10. Yeah, slow and steady wins a race. So my volume is actually 3 pi over 10. And that's the volume. Right? Okay, that's it. So when you have that washer method, you're just taking, instead of just a straight up circle at the end, you've got that washer. So it's the top radius minus the bottom radius, because again, it changes, right? This changes from the distance to get to the bottom. This changes the distance to get to the bottom in terms of that radius. Okay, see, it's not so bad. You've totally got this. Circles, area of circles.